Now let's add the rotation capability to our camera. So we want to rotate the camera whenever we press E or Q. So first things first, let's add those as input actions, because we want to be able to detect them. So input action, which is going to be the camera, rotate right or left. So let's add those two actions here. And let's add to rotate the camera to the right is going to be E, or to rotate it to the left is going to be Q. Let's close this and let's build a new function, which is going to be another public function, which is called camera rotate. And this is also going to use delta to normalize the function, and this doesn't return anything, so void. So if we detected on the input the action being pressed, so if action is pressed and the action we want to detect is the camera moving towards the right, rotating towards the right, that is, we want to change the rotation of the main 3D node of the camera towards another rotation position, another rotation value. So we want to rotate the camera towards these, so not actually rotating the camera node itself, but actually the main node that holds the camera. This is so we don't run into issues with rotations. So in order to do this, I'll be actually added its global rotation. So it's not the local rotation, it's global. So this is pretty important. So be adding, changing its y to be equal to a speed. So let's now add the rotation speed for the camera control. So this can be a variable to you change along the way, but for now I'm going to be adding as a constant. So this is going to be our camera rotation speed, which is a float, and it's going to be equal to 1 for now. Let's copy this property and let's add it here, multiplied by delta. So this is what happens whenever we press U, but we also want to do this whenever we press left. And I believe this works. And now we just need to decrease instead of adding the value. And with just these lines, now we have the possibility to rotate the camera whenever we press those two keys. Let's now copy the camera rotate function and be running it inside of here as delta, with delta. So now we can, on the process function, we will be able to pan the camera, move it, and after it rotates, and apply the movement velocity for the movement or panning. So now let's run the scene, and whenever we press U or Q, you can now rotate the camera. So more stuff for us to move the camera around. Now the last thing to do is to implement the zoom capability of our camera system. So let's go right ahead and add the actions for those. So this is going to be an input action for the camera zooming in. So zoom in, I'm going to copy this and zoom out. So for the zoom in, I want to do a mouse wheel up, or I also want to do with the keypad and keyboard with on the keypad add button. For the zoom out, the same thing, but the mouse wheel down, or the minus on the keypad. And you can add any input you want here. Now let's go ahead and change some things here. So the camera zoom, let's add a new function, which is going to be camera zoom, and this also uses delta to normalize its movements. And let's say if our input has detected an action being pressed, which is going to be the camera zooming in. If so, we are going to set the camera zoom velocity. So this is where I need to add a new variable. So we have a variable to control the movement velocity. Now we need a variable to control the zoom velocity. So this is a var called camera zoom velocity. And I believe this one is a float, because we do not have a 3D axis. We can only use positive or negative to move, zoom in or out. We don't need any more control over that. So here we can press Control Space and add to the camera zoom velocity, which is going to be, we approach the camera by the camera zoom speed. So we also need a new function here. We now need a new constant, that is, which is going to be the camera zoom speed. And let's do a 4 here. And now let's do camera zoom speed is going to be that multiplied by 1000. So these are the values I have tested. You can change them and see the effect it has. So this is for the zoom in. For the zoom out, we're going to do the same thing, but whenever the input is zoom out. And of course, because one is adding value, one is subtracting, we want to add this value instead. So it moves on the other direction. So this is just calculating the cam zoom velocity, just like the panning and the movement is changing the camera movement velocity. But we need a function to apply the zoom velocity, such as we are applying the movement velocity. So we're going to need a new function here, which is going to be for the camera applying the zoom functionality. So we're going to call it applying the zoom velocity. And this is going to be asking for cameras, such as the previous function did, which is going to be a camera 3D, and this function doesn't return anything. So let's do the following. Here we can actually control whether we want to move the camera forwards or backwards. So if our camera velocity on the zoom one is going to be different than 0, we want to say that we want to translate the camera backwards or forwards. So translate the camera object local, and because this is a 3D translation, we need to build a vector tree. But of course, we're only moving the camera on its z-axis. So here is where we pass the camera zoom velocity. And finally, we set the camera velocity to back to 0, because we already applied it. And if on the next process frame we continue setting the velocity, it's going to continue to call this function on the next process frame, thus moving the camera backwards on its zoom. So now let's apply this function, and I can actually do this as being our camera 3D. So here we can actually do this. What was the variable of our camera? It was camera 3D. So now, so different from the movement function where we move the main 3D node, this time we're actually moving the camera. So that is why we need to pass here the camera. So just using these functions here, we can now simply rotate the zoom, and it's not working. So let me see what that is all about. Of course, we forgot to calculate the zoom here. So we only apply the velocity, but not actually calculating the zoom itself. So after we move, we pan and move, we're going to basically calculate the zoom. So now if we run our function and whenever we press minus, you're going to see that we actually zoom the camera, but it's too fast. So let's go back here and let's reduce 10 here. I think that is good enough. But there's a problem here. Whenever we scroll the mouse, the inputs are not being captured. So this issue I could not actually solve. So sometimes inputs get finicky inside of Godot. And I believe this also is because the inputs of the mouse are actually being captured by something else. So instead, we are going to actually detect the camera zoom with the mouse with another function. So the process function is not being able to capture the zoom functionality, despite we have added it here on the input camera zoom action. So instead, what we're going to do is to override another method, which is going to be for unhandled inputs. And we want to detect if the input being passed here, if it is the input of a mouse event button. So if our input event is equal to a mouse button, there we go. So if that is the case, we are going to call the function of the camera zoom with delta. So delta does not belong here, but we can actually grab from this object by doing a get process delta, which happens to be a QuickTime shortcut function to call the process delta from a given node. Because this function does not pass as delta by default, such as the process does. So we cannot do that, so we instead have to pass it using this. So now the function of the unhandled inputs has been able to detect the mouse wheel, which I don't know specifically why the mouse movement is grabbed on the unhandled but not on the process category. So something finicky about that. So as you can see, it works, but now we have a bigger issue. We can actually zoom past a given bound. So let's actually define some limits to this. So let's go ahead and add a new variable here, which is going to be the camera zoom range. And it's a vector2, because we want to confine the minimum and maximum under a single variable. So we're going to be using a vector2 for this. So for the minimum zoom distance, I'm going to be keeping as 50 and 200. So keep in mind that this is not zoom levels, it's actually the camera Z position. So the way we are doing zoom with the camera is actually moving it on the Z position, not actually setting anything here when it's FOV to actually do the zoom or anything else. So this is actually we detect the movement of the camera on the Z local space to see if it passes this range. And the way we're going to do this is by going here on the camera zoom function. Whenever we apply the zoom velocity and calculating that if it's inside of the range. So whenever we have a camera zoom velocity, we want to calculate the zoom. So the way we are going to calculate the zoom for the next process frame rate is by adding a new variable, which is going to be calculated zoom, which is a float, and it's going to be equal to our camera position on its Z minus adding the camera zoom velocity. So whenever we have the current camera Z position adding the zoom velocity, we're able to identify the next calculated zoom position. And of course, this is not what I want, is camera its position Z. So now the next thing we want to do is simply calculate if this zoom is inside of view range. So we want to do if our calculated zoom is higher than the camera zoom range on its X position, which is the min value we set up for this variable. So if you double click here, you're going to see that it's going to be equal to 50 or 200. So we first check if its position adding the zoom velocity, if it's inside of the minimum range, and this is an and not an or. So both conditions have to be true. If our calculated zoom is less than the max value we set for camera zoom range, which is stored under the Y position. If that is the case, now we can actually apply the zoom speed. So we will only be able to translate the object to apply the zoom if we are inside of their range based on the calculated zoom, which is simply the position of the camera on its Z, adding the zoom velocity. And zoom velocity is calculated if we press the zoom actions or the mouse wheel. So now if we run the scene, we should be able to zoom the camera to a maximum, which is 200, or zoom inwards to 50. So now we have restricted the zoom functionality of the camera to a single point. But now we have another issue. Because we are moving the camera with a normalized movement, whenever we zoom in, you can see that the camera moves pretty fast. And whenever we zoom out, the camera moves pretty slow. So why this is happening? We are actually moving the camera based on a fixed amount, which is 1 multiplied by delta. But whenever we zoom out, the camera is too far from the ground. We need to actually move the camera faster in order to keep the same speed, because now the camera is much more far away from the objects of the screen. So in order to create a normalized movement for that, we have to calculate it based on the camera zoom level. And this is actually pretty simple to do. Let's go where we apply the movement velocity and change some things. Let's now calculate the camera zoom speed based on some parameters here. So let's create a new var, which is going to be our camera zoom speed, which is going to affect how we apply the velocity, by how much. So this is going to be a float, and we are going to remap the values. So this will be easier if I show you instead of try to explain it. So let's use the remap function here, and I'll show you what I mean. So let's do the remap function, and there's a bunch of different arguments and an explanation here. but it'll be easier if I just show you what it does. So first value of the remap function is what value are you trying to remap? It's going to be the camera position on its Z value. So we want to access the camera, and I believe we call that camera 3D. So actually I'm going to rename this. So let's double click here, press Ctrl R and replace this with camera, because it's going to work best. And this will replace every single variable inside of your code. So let's do now the position Z. So this is the value we want to remap, and it's going to say for the next argument, where does it start end and where the remap starts and end. So yeah, it's pretty confusing, so let me just show you. We want to remap the zoom range X and the camera zoom range on its Y. We want to remap it to the camera move speed. So here is something that I have not set up. We need a variable to control the new speed we will have with the zoom one. So we have now a value that controls the zoom range minimum and maximum. Now we need a variable to control the velocity of the camera when the zoom is up close or when the zoom is out. So basically, let me just run this function here. So let me just comment this by press Ctrl Q. And whenever we run the game again, whenever the camera is far away, we need a velocity that is much higher than whenever we are close to it. So we will be creating a new var to control this. So let me uncomment that and create a new one, a new constant here, which is going to be our camera move speed. Now this movement speed is going to be the minimum and maximum movement speed whenever we zoom close or far away. So let's do a vector 2, and I'm going to be putting values pretty similar, but I'm going to explain you how this works. Whenever the camera zoom is at its minimum, it's going to use this velocity to move the camera around. And whenever the camera is on its maximum zoom range, we want to apply this movement speed towards its velocity. So this is going to be used on this function here whenever we remap it. And we want to remap that to the camera move speed on its Y. And I believe that's all the parameters, so we can already close this. So now let me show you how you can use this. Whenever we apply the camera movement velocity, now we can actually, instead of multiply by 40 to set up the speed, we can multiply by this remap value. So we are remapping the camera zoom position Z to a new variable, which will be multiplying the velocity. This remap is going to say that whenever the camera Z position is on the minimum zoom range, we want to apply this speed, and whenever it's on its maximum zoom range, we want to apply this speed. This apply, which I am saying, is going to set up this var, which is being used to multiply the camera movement velocity. So doing that, whenever we run the project, whenever the camera is far away, we are using the maximum move speed we set up on that constant, which is 100. And whenever we zoom in, the remap is setting back to the minimum one, which is 40. So I can show you what that looks like. So if we extrapolate, if we put 4 and 200, whenever the zoom is on the minimum level, it's going to move at 4, and whenever we are on the maximum, it's going to move at 200 speed. And we can see what that looks like. So whenever I zoom in, you're going to see that I move at 4, and whenever I zoom out, I'm going to move at 200. So this is just exaggerated for you to see what it does. And it's going to interpolate that value using the remap function to do the rest of the values along the way. So that is where you use that function. So the remap function does this kind of magic. It's basically creating an interpolation between two values and assign two different results based on it. And we are assigned that to a variable which we are using to control the movement velocity of the camera. Okay, so finally we have here panning of the camera, rotation of the camera, movement of the camera with the keyboard keys, and also the control of the arrow keys, zoom of the camera with the zoom wheel, or by using the keypad controls on the keyboard. So now we have a basically movement system. And now we could add more code to this, like the rotation of the camera on the x-axis and stuff, just as I did on the previous video, but I think I'm going to keep it as this. We now have a basic RTS camera. And if whenever we press ESC, we exit the viewport. If we click on the viewport, we can now move the viewport and it's confined, so the mouse movement is confined. And we actually can set stuff like changing the maximum distance of the shadows here to some effect we want, or whenever we click on the viewport to go back to it and double pressing ESC, we now can exit the project. So all of this code has done that movement. So now we have a basic camera system with some basic prototypes to start your RTS project. So yeah, I could keep this short and do not explain anything at all about the code, but I think you guys will want to see what that looks like. If you want, you can just copy the code as you can see here on the finalize. It's very simple. Once you understand it, I think you can do on your own. But if you want to understand, I have to do it step by step, and yes, it gets the video to be bigger, but I think you have the full opportunity to see the final explanation. So yeah, I do not explain everything like what are funcs, what are vars, because this is basic knowledge, which you can learn on other types of tutorials. So this tutorial is more about building the RTS prototype rather than teaching you basic stuff about Godot, which you can learn on various videos on the internet. If you're interested in a beginner basic tutorials, you can actually send me messages and I'll see what I can do. But for now, I am sticking to this project, which is to build the RTS. So yeah, we have now movement with the camera, rotation, and all the good stuff. Basic stuff for the RTS genre, but you see how long it took to make. So yeah, this should cover the basic mechanics. If you want access to this project, I'll be posting under my community tab. If you are a member of the platforms I currently have available, which I believe for now it's only YouTube, but I have plans to add to a Patreon page and see how that looks like. And if you support me, you'll get access to this entire project as it is. And we'll be continuing this project on the next part, adding more mechanics and gradually building our RTS project. Different from the previous project, I'm going to strict for linearity, so I'm not going to be doing anything outside of the videos. So rest assured that the next part will be continuing building the RTS, and I will do step by step, just like I did with this video. So sorry if the video is too long, but I think it's best to show you everything I do. And you can also rate this video and say it's too long, it's too short, and give me feedback based on that as well, if you would like. So that is all I have for you guys. Hopefully you have enjoyed this tutorial, and I'll see you on the next video. So thank you guys for watching, and I'll see you on the next one. So bye for now.